Bem-vindos to one more episode of the Type Theory for All podcast. As always, this is your host Pedro Abreu, and in this episode we have an amazing conversation with Eduardo Rafael. He's a self-thought programming languages enthusiast, YouTuber, Twitch streamer, multi-skilled programmer that has worked in different aspects of computer science such as PL, operating systems, blockchain, and many other stuff. In this conversation, we will talk about his experience as a developer and hacker that didn't follow the conventional paths of going to school, and what are the strategies to navigate the vast ocean of knowledge without the guidance of teachers or institutions. But before we get into this episode, don't forget to join our Type Theory community on Discord. Becoming a Patreon on Ko-Fi with any amount, you will gain access to exclusive perks such as submit questions to our guests and watching the recordings. Don't wait any longer, go to typetheoryforall.com and become a contributor to the show right now. So without further ado, let's get into the episode. Alright, welcome everyone to one more episode of the Type Theory for All podcast. This is your host, Pedro Abreu, and today with me, again, I have my co-host, Dan Teika. Did I get it right this time? Come on, dude.
No, you make the same mistake every time. The Y is obviously silent.
Plukin. There we go. I got it now. How are you doing, brother?
I'm doing all right. Not too bad. Calling from Chicago, Illinois. Beautiful Chicago.
How's the weather over there?
It's exactly the same as in Purdue, I think. It's a little bit annoyingly cold, and it warms up during the day so that you have to kind of shed your coat like some kind of animal that, sheds skin over the course of the day.
I don't think it's fair to say that it's kind of like the same, because Chicago is known as the windy city, right? The wind city.
I haven't noticed any wind yet.
No?
I guess we're due.
Good.
We'll see.
Good. But anyways, and our guest today is Eduardo Rafael. Welcome to the show, Eduardo. How are you?
As they mentioned, I'm doing fine. Unlike then, weather, I'm calling from São Paulo. It's insanely hot, and it's hot all day at this point. So just hot.
Dude, São Paulo is already so hot, and especially now that it's this very hot time in Brazil. You guys must be dying over there.
Yeah, I have AC here, so it's not nearly as bad. But I didn't leave my place for the last 5 days or so.
It's just bunked in against any weather. And, that's nice.
Yeah, that's
dude.
pretty much it.
Is that because of the heat or just because you're a really serious programmer?
It's obviously because I'm a serious programmer.
Dedicated to his craft. Okay.
Anyways, Eduardo, how about we start with you telling us a bit of your story in computer science? How did you get into programming languages? What are the kind of stuff that interests you?
That's an interesting question overall, because I'm not sure there is that much of a story. So I have no, formal training. In fact, I did not finish high school. So, at some point I start playing. I don't know even how to say it. I start writing code for games, game mode in general. So San Andreas multiplayer, the mod platform for playing GTA San Andreas in multiplayer, I guess, and Minecraft modding. And so I started doing that, and I was about 12 at that point. And then 7 years later, I got a job as a front-end developer. Then I got a job as a full-stack developer, embedded developer, and a blockchain engineer. And yeah, along the way, I was just exposed to a lot. And especially on my first job, I actually needed to. We had a huge, not huge, but a big code base. And we were completely understaffed, so it was 2 to 3 engineers doing managing a huge code base, and so there was some refactoring needed, and that's how I got into hey, there is this thing called an AST, which allows you to view the code as data. You can manipulate AST, generate, do some transformations, print the code back, and by doing that, I got some really nice improvements over the project. And then we were in AngularJS something, but AngularJS was before we had CommonJS and ES modules and whatnot. So the main goal was like, how can we move to something like Webpack, which meant hooking on the Webpack and making a plugin for Babel, I think at the time, for some reason. I don't remember the details, which meant more compiler work. Got that in. Again, improvements. And then on my third job, where I was working mostly as an embedded developer, we were writing C++ and JavaScript, and it was not great. It was just not a great experience. And so I started trying. At the time, I was playing with ReasonML for front end, and so I started trying with OCaml native to see if we could run on those devices. And I never ended up getting that to production, but that got me to like a very deep path to like, okay, now you need to learn compilers, now you need to learn programming languages, now you need to understand, okay, what is this type system doing, because you want to enforce some invariants. And when I got into the blockchain space tries to use formal methods to some extent, mostly to like, try to avoid people stealing $100 million again. And so, yeah, it's pretty much that. And then I just kept going, and I don't know. I learned a bit along the way.
That is actually pretty amazing. I'm impressed, because I think the kind of stuff that we do here in programming languages and compilers is already very hard, and you didn't go to university, you didn't do any of that. That's actually pretty impressive to me, at least. I really like the part where you like how you got into programming to do mods and like to change things that you were playing with. That's actually how I got into programming as well. I used to run some bots like for some MMO that I play, and I started getting more into it, and then you have to start doing some actually scripting, right? It's really fun, actually. It's really fun. Good times. But
one thing
okay.
it makes me wonder is since you were so, you really jumped into learning coding stuff. I wonder, do you feel like there's a way that we could be better as educators to when people are in school, if they want to pursue that type of stuff in school? Do you feel like there's maybe like a game-based curriculum or something that you feel would be effective, or is it just that some people have to go out into the world and learn that way?
I think it's mostly a failure of math education. In fact, it's like it helps to be like, hey, let's do gaming. It helps to do anything that is slightly more concrete to people. But at the end of the day, you need to have some level of reasoning, abstract reasoning, and you need to, in my opinion, you need to have algebraic reasoning. You need to be able to, to play around with those elements, with those terms, rewrite them to see what is going to happen, to follow the execution. And in my case, I always had a good time with math. And so when I needed a bit of it, I actually already knew the basics of algebra, elementary algebra and whatnot. And so it was not hard. But I think it's a failure of math because, in my opinion, it's by far the best way of developing mathematical maturity is by playing with the things. And at least for algebra and even arithmetic and trigonometry and a couple more, and geometry overall, like writing software for it. If you can write the software for it overall, that meant that you understand what you're doing. But because computers are still relatively a recent thing, we don't know exactly how to use those to like, hey kids, let's play, let's implement whatever equation and let's see what happens. And for me, that's how I got better at mathematics over time. But yeah, I am not a strong believer that if we just gamify everything, if we make teaching computer science and mathematics like playing on Duolingo, and I actually like Duolingo, but I think it's just not the silver bullet that everyone tries to play for.
Mm-hmm. You must have developed some kind of like autodidactic, like teaching yourself skills over time, or was it always just like, oh, I happen to be doing this thing and I happen to pick this up and there's really no method to the madness?
I was the annoying kid. There is no method, just pure madness, I think. So I was always the kid asking the questions that you should not keep asking. And, at some point my parents were really upset at me. And I was like, okay, so I just can't, if I keep asking them, they are not going to answer me. But then I got this amazing thing called the internet. And getting access to it was pretty good. And so I kept asking questions. I kept going around, trying to figure out what to do next. And I think people miss the point of theory overall. People think that theory exists for you studied on the university in this clean room environment. And I'm like, no, the reason why we're doing theory is because we want to do the practical one, but we actually want to have the overview. Like, we actually want to understand, why are we doing exactly what are we doing? And if you have some level of mathematical maturity, again, I think applying theory becomes natural, and then learning more or less goes into an exponential curve, where at first you're fighting with all the concepts, but at some point they just start to help you out and you get faster. So yeah, for me there was no madness, no method, just madness and a lot of time. I don't know, it's been half of my life at this point, and I probably have 15 to 20,000 hours of playing around with software and computers and hardware and whatnot.
Mm-hmm. Yeah, I mean, that reminds me of, for example, the way that we teach parsers in a programming language course. I think we just go right into the theory. When a parser is the easiest thing in the world to just try and implement yourself. You end up writing something that's probably recursive descent. And then you'll encounter some of the problems that are with recursive descent. You'll get into these LL ambiguities. And if we just teach it the other way around, we say, try and do this, and then look at what problems you found, especially when I gave you this particular grammar, then you get the theory and you go, oh, I can do this. Oh, I can just write out the rules and I don't even have to write this annoying parser. Although, I mean, there are sometimes a lot of actually mature projects still use recursive descent instead of an LR parser generator. But I agree totally that we should start with a practical foundation before we start teaching theory. Theory is all about trying to get to that. Especially if you read a paper, it's always a practical example, and then they develop a theory for it. So why don't we teach it that way? I mean, some of us do, but...
Yeah, I think, you mentioned teaching parsers and whatnot. I think parsers are by far the most boring part of programming languages. Yeah. And I hate that so many courses. I was talking to a friend and he was like, no, my compilers class was essentially how to write a parser.
Yeah.
And I'm like...
Yeah. Yep. Using that fucking Dragon book.
Yeah, exactly. I'm like, dude, why? That's there is no fun on that. That is just there is some fun after a while, but that's not what you want.
That's not where the meat of programming languages is. You want to do programming languages, right? There is so much more interesting stuff to be digging down into. The parser and the lexers, kind of, I don't want to say it's a solved problem because it's not. There's still interesting theory going on, but right now it's just there's a bunch of algorithms that you can just apply, right? So
yeah, he kind of mentioned that it's a solved problem. I know for sure it's not, but it's more or less something like, hey, we actually know how to do. You just follow a set of rules. You apply the tools properly. Sure, you probably need something better for error messages and whatnot. Many here, OnoCamel does a really good job at that. And maybe you want to go back to recursive descent if you want to go to production and whatnot. But it's like, come on, just give people a parser, let them play with AST, let them, run an interpreter, try to type check STLC or something like that. And it's so much more fun.
So when we were talking about learning things yourself and being an autodidact, is that the word autodidact? Something
I
along
think
those
so.
lines. Learning things by yourself.
Self-thought?
Self-thought. Good. So I have this feeling sometimes in my life that like I'm trying to learn something by myself, and it's really hard. It's really hard to learn something by yourself because it's as if you're kind of like in this very dark room and you have to keep looking around and like you don't know where anything in this room is, and you're trying to find a light bulb to turn on and you can actually see what's going on. So you're completely lost, right? And on the other hand, when you're actually like taking a class or you're being taught by someone who's already been in that dark room, he will lead you through it and help you to navigate and make your life kind of easier, right? So so my question is, have you ever been somewhere in your life where you're like, I don't know, like if I had someone to help me out, or if I knew how to navigate these things, I would have, like things would have been so much easier for me. Or, like probably when you started actually working, you have contact with people who were extremely smart and could help you out. And have you ever felt anything along those lines? What is your thoughts?
I think mostly it's a tested skill overall. Like it's something that after a while, I don't feel that much that having a third party helps that much. Besides when I'm completely locked on something, but you more or less learn how to find knowledge. You more or less learn how to go through papers and go through books and try to find. And then one thing that works super well for me is like trying to find people that are working on whatever am I working, but on Twitter. And so like hot takes help a lot because POT people seem to also love hot takes, but sometimes it helps. And memes, I really like the locally nameless one versus Hoas because I didn't knew locally nameless.
Yep.
And now I'm the biggest fan. And so
Nice.
It was helpful because at the time I was looking for ways of representing that would make type checking easier, and it helped me a lot. But yeah, at this point, I don't really think that asking questions in that way is that helpful to me. But I really think it's helpful to ask experts on any topic. Not because of whatever they publish, but because of what they didn't publish.
Right. Yeah.
So like the things that they tried, and it's not worth to publish because sometimes it just doesn't work. And so you ask them, hey, why does this naive solution doesn't work? And they're gonna be like, haha, been there, done that. It doesn't work for A, B, C, D.
Yeah.
And that is helpful, but I also think the best algorithm overall to learn is the Feynman algorithm. It's a joke of like you write down the problem, you think real hard on it, and then you write down the solution. It probably works if you were Richard Feynman, but to some extent it's great to develop intuition. You keep doing that, you go take a shower because you're sad, and then you come back and sometimes you have the solution, sometimes you don't, so you keep trying. And over time, I feel like that helps you to develop a much deeper level of intuition than just like going directly through the literature.
Right.
Of course, it's much more time consuming. It's not something that you can apply for everything, but I really think it helps, like on the long term.
I was reading Alan Turing's biography, and they definitely mentioned that one of the things that Alan Turing would always do is that if you come with him with a problem, he will not, he will take the problem and leave the room. He will not wait until you explain what's going on. He will try to, think about it for a while and actually poke things around. And then after, when he actually has some idea of, he understands the problem, then he would come back and they would discuss. So it's kind of like what you're saying, right? Like you first write down the problem and you think really hard about it, then you're in a position to actually, do something with it. Sometimes,
Yeah.
sometimes I feel like, I don't know, like even going for a nap or actually sleeping helps, right? Then you wake up and sometimes the solution is just there. It's weird. It's weird how the brain works.
Yeah, the neuroscience of sleeping is pretty cool, and for me, it's also definitely a thing. That's why I mentioned, like, you need to put time, because you're gonna stress yourself as much as you can today, and then you're gonna
Right.
sleep,
Mhm.
and I noticed that I was very deep into something whenever I start seeing it on my dreams, and people joke around about I dreamed about code and whatnot. It's impressive when you dream about code, and it actually kind of makes sense when you still wake up, and I got some of those over time of like, hey, my brain is just, I've been just playing around for 6 months with this, and now when I sleep, sometimes I see it. And at some points it kind of does make sense, and it helps. And especially when you wake up, it feels like your perspective on the problem kind of shifts a lot every time that you go to sleep with something on your mind. But that is something that, first, it does not work for mass education, because you cannot say, hey guys, time to take a nap. Let's see if you learned about parsers or something like that. But I think if you're trying to improve yourself, you should definitely focus on sleeping.
But I definitely agree that there is also this point where you have to put in the work. You have to think really hard before, like you take the break. You really have to try it out, right? Really understand what's going on. And then the brain will do its thing.
Yep. We're smart.
Did you ever feel like you worked for so long on a problem that you couldn't stand it anymore? Like when you get jaded with the food, like you cannot stand that food anymore?
Yeah, that's when I mentioned pure madness, I think that's half of the thing. I do not have discipline, but I mostly don't get tired of doing the same stuff. Like I can keep going and doing it, but in general, I'm never like 100% focused on just one thing. So it doesn't burn me out at all. But I keep going over and over and over to a problem until maybe I found a solution. Maybe I forgot the problem. Maybe the problem is not relevant anymore because I was asking the wrong question. That happens quite often. But yeah, I don't have that much the feeling of getting jaded and not being able to stand up problem anymore. But sometimes things become not interesting anymore for whatever reason. I can still keep going. It's mostly that I don't know. I just wander around a lot, and yeah, that kind of works for me.
In a way, you're kind of more of a true researcher than we are, because in academia, you pick a project and you kind of have to stay with it. It's really hard to negotiate your way around it. It's mostly like your advisor wanted you to ask this question, and so you kind of keep working on that forever. And I know that I've had the most fun and the most I'm well. You do have to have a bit of discipline. I think you're not giving yourself enough credit for having discipline in terms of like the direction that you're going, but that you allow yourself to kind of flow around. That I'm envious of. Both Pedro and I are just like, man, that sounds like a good way to go about things.
Yeah, I think we have a question about Teika later, but I think Teika is a good example of that, which is I was like, okay, OCaml is full of problems. That's not the wording that I used at the time.
You can swear in this podcast. It's fine.
Okay, so yeah, I was like, OCaml is full of shit. And I was like, come on, we can do better than that. And then I started wandering around, and I played with Coq a lot. And then, I knew Haskell. I tried again a bit of Haskell, but it felt there was something missing on that. I still think Coq, for example, is the best programming language that we have.
Oh, yeah.
It's like amazing. The only problem is a programming language is not made of, PL researchers. It's also made of a community and tooling, and it's not great when your compiler starts to give random exceptions because you abused inference too much. And the average experience writing calc, it's like if you stray away just a bit out of LTAC and writing tactics and whatnot, it just becomes a mess. Yeah. And even that is just. And so I'm like, okay, can I do better? What there is to be thought about this problem? What are things that are super relevant that we still don't have in languages like OCaml, Haskell, and whatnot? For me, the answer for both end up being dependent types and linearity. And so, but that is, at that point I decide, okay, I'm going to make a programming language, going to spend time on it. Is it going to be great? Probably not. But I do need to go through all the steps on design. And I've been doing this for a year and a half, and it was a great way of like both widening my knowledge and getting deeper into a couple things. At first I was like, no, we don't need dependent types. Dependent types are too much. And now I'm like, dependent types is the bare minimum that we should have.
Wow.
And so, yeah, some mood swings here and there. But yeah, for me, it's mostly, that's the only discipline that I have that is like, I'm keep trying this project because I decide that I'm going to do it. At some points it becomes painful, but I can go away for 2 months and then I go back and whatnot. But it's not much more than that. For example, I have a deadline for on next Sunday. I'm going to give more or less a workshop on some of the stuff that I'm working on. And the problem is I just deleted the type checker 3 days ago. And to be fair, it's mostly going to be on a toy version of what I'm working on. And so the new type checker is almost ready. And I plan to start working on the LSP very soon, like today. But yeah, so my discipline, it's not great. It's just that whenever I need to put a lot of time, I can do it.
So tell us more about Teika. So you said that you were a little fed up with OCaml and Haskell, even Coq kind of. So your vision is, let's try to build something that solves some of these problems.
Yep.
Is that right?
For me, the main goal was exactly that. I described a couple times as the next generation of ML. So, and I think we have this clear training of like, at first we had an ML, which was pretty much linear, and then everyone always seems to like system math and wants like higher rank polymorphism and whatnot. And we got that through in all of them through some different means. And then we got very deep into modules. But keep in mind, like dependent types was not a known thing when modules start showing up. And everyone was like, there is something weird about this. Let's say I want to define a module, a local module and whatnot. And that started becoming a problem. And when Camel started showing up, like they just decide, okay, let's do a lot of hacks to make modules work. And that's how you got OCaml. But parallel to that, dependent type theory was going. And we have a lot of ways nowadays of describing modules without describing dependent types. But all of them lead to some weird things. So for example, in OCaml you have functions, plain old functions. You have functors, which are module-to-module functions. And then at some point, people are like, oh, well, we want first-class modules because that makes sense. And now you get a function that takes a first-class module. It can return a first-class module or not. So you also have first-class functors because functors are modules, you can pack them. And whenever people start discussing higher kind of types on the core language for Camel, for example, we add another kind of function. So whenever you read about modular implicits and modular explicits, it's another kind of functor, in fact. And it's like, at some point you have 5 different kinds of functions and they all do about the same. And you also have type constructors, I forgot about those, which are like just a kind of function. And you have for alls because just another kind of function. And at some point, it's just too much. And so I was like, okay, this does not make sense. And at the time, I was asking a couple questions of like, what is the difference between modules and records? What is the difference between objects and records? And like modules and records, mostly it's that modules you can depend on types. So you can have a type inside of your record. That's a thing that you cannot do on normal records in OCaml. So they are essentially the same, but modules are dependent records. The same thing goes for what is the difference between functors and normal functions. It's just that functors are dependent functions. More or less, there is a lot of magic details because OCaml is bad. And I was like trying to find, okay, what is going on here, and how can I play around, and how can we unify those? And then I got into 1ML, which is a calculus from Andreas. I don't know how to say his name.
Abel? Was it Andreas Abel?
No, it's Hosberg.
Okay.
Yes, Andreas Hosberg, which pretty cool, but it's still not great. And then I got introduced to a lot of concepts, and at that point I was like, yeah, let's go with dependent types. It took me 6 months to accept that, but after you accept dependent types, everything started making so much more sense. But at the time, I didn't have intuition for dependent types. And I was like, besides of that, there was this big elephant in the room called Rust, which was like, okay, Rust is pretty much OCaml, but something is different. And people say it's the borrow checker and whatnot. It's mostly about linearity. Rust is a linear language. And borrow checker is just, sugar to that. And I was like, okay. And linearity is really cool because it solves all the problems of like resource management, closing and opening sockets, file descriptors. You can even do, manual memory management by hand if you want in a safe way. Especially if you accept dependent types, then linear types become super cool. And I decided, okay, what happens if I think about a language that has those two features? So it's a dependently typed language, but a linear one. And at first I was like, linearity should not be the default. Linearity should be like another kind. So you have normal functions and you have linear functions. But over time I end up noticing that like it's actually easier to start with purely linear functions and make them more convenient. A bunch of techniques along the way, but you can do that. And it becomes super convenient and super fast. And you'll even get a couple things that only matters if you have dependent types. So that's what I decide. Then I start playing around. And it turns out that everything related to both of those are bad. The theory for both are very recent. We did not explore a lot. There is not a lot of type checkers wrote on those. I think, linear types became a thing when Philip Wadler wrote Linear Types Can Change the World, which is a really good paper, by the way. And not that it became a thing, it was already a thing, but like it became popular as a programming language concept. And that was in the 90s. So and Rust was the first one to go to production, and it was in 2013. So those are very, very recent ideas overall. And needing to go over it on the literature, it ended up being fun. But a lot of reading, and so that's what I've been doing for the past year. It's been a year since I accepted. Okay, those are the goals, and I think linearity, dependent types, and also what was the last one? Right, inductive types end up being a real pain.
Oh yeah.
And
all the way with universes and all of that.
No, that's not even the problem, because one of the biggest advantages of accepting linearity, and even if you accept multiplicative linearity, so like instead of the function taking one copy, it can take 2, 3, 4 n copies, but it needs to be a natural number. It's that you gain cut elimination for free. So you can drop universes. You can just have type in type, and your system is still logically consistent and strong normalizing. Because even the untyped lambda calculus, the linear untyped lambda calculus is strong normalizing. And it's actually a super easy one to show that that's the case. And so that was one of the, okay, this is cool. This is really cool. If we accept linearity, if we start from there, we actually have strong normalization without going through universes. At first I was in love with universes, and then I was like, come on, that's so painful.
It is.
It is. And my current opinion on that is that it's just, it's just a caveman solution for termination checking. So it's like, and I know that, it comes from set theory. Rousseau was stratifying things because of his paradox and whatnot. But at the end of the day, I think if we just have termination checker, it's better to accept, okay, we have type in type. It's way more convenient. Go back to original marking of type theory. And now from that, we start building up. And yeah, I had a lot of fun. On that. There is one paper that I really love that teach me a lot about universes in predicativity, which is called Using Predicativity Implicitly Implicit, from Stephen Monnier from the University of Montreal. I still mention it a couple times whenever I'm discussing a couple of ideas, because it shows a couple interesting relationships. And overall, I end up, okay, we just need strong normalization and subject reduction. And if we have both, it doesn't matter. Like, I do not care that much about the categorical interpretation of whatever does it mean to be type in type, or like how does that relate to set theory. What I really care about is that I have a rewriting system that has these properties that allow me to depend on everything, and that is kind of ergonomic and fast. And so it's a lot. But yeah, I don't know how to interpret the calculus that I have, but I know, well, I don't know because I do not have the proofs, but I have the gut feeling that it has a couple good properties.
Mm-hmm. Mm-hmm. I think one of the main issues with dependent types, though, is because, like starting intertwining programming with proving things, right? So if your function type is a little too complex, then you end up not only, you actually have to come down with all the terms of the proof that thing is correct, right? Did you think about this for Teika?
I did think, in fact. I think, actually, people think about dependent types, they think about proofs. And no offense, I think that's one of the failures of the academia here. Academia, I don't know how to say that in English. Which is, dependent types for me, it's not about that. It's about like, hey, I have, I want to make an array. And if you have linear types, you can make an array safely. And I want to take, to make it, I need to know the size of the array. So I have an integer. And I want to say that the integer is bigger than 0, or bigger and equal than 0. Sure, you could say, oh, but you can just take a natural. But what if I don't want to have 0-sized arrays? What if all my arrays should be bigger than 0? You can just do that. Oh, is that a proof that the length is bigger than 0? Yes, it is a proof. But I really don't like thinking about it in that way. It's like, it's just a way of describing, hey, this is a requirement. Here are all my requirements. And I think if you do some limitations, especially my solution for that is mostly through proof irrelevance plus basic subtyping, which is what everyone seems to going towards.
What typing?
So it's like, sorry?
What kind of typing you said?
Subtyping. So it's like, it's an intersection type, it's a dependent intersection type, plus some subtyping, and the main restriction is that only one of the sides can be relevant. Everything else needs to be irrelevant, because then you can erase it. You do not have performance cost. And then you can do your subtyping erasing to both sides. And it becomes super convenient. But even without it, if you can just combine things, if you can just pass pairs around, it's not as bad. It's just that it doesn't mean that if you have dependent types, you need to use them for everything, which is it's different if you're writing formal proofs. If you're trying to show, if you're trying to show Fermat's last theorem, for sure that is going to be completely different. But if you're writing front end using React, you don't want to like add 100 constraints on your function. You just want to say, this string needs to have at least a length of 5 and at most a length of 12, because otherwise it's going to break my layout. You want to say that, hey, this request needs to return one of those values because that's your specification. So it needs to return like maybe a 200, a 204, or a 404. It cannot return like a 400 because that is not on the specification. And so things like that is the way that I see the benefit of dependent types. And also to educate people about it. Because like most people seem to think about, we have generics, and then we have, we have functions, and then we have generics. Whenever you drop that, you just have functions. You have functions from types to values, from values to values, and even the opposite, which is values to types. And so it becomes easier to say, hey, you can just write a function. You can just abstract over this. Oh, is it a type? It doesn't matter. Is it a term? It doesn't matter. You just add the function, annotate the type, or if you have inference, just let the compiler figure out. And it's one less thing to teach to people. It's like, and that the same goes for modules. It's like, you don't need to teach modules. You just teach, hey, we have records. Oh, by the way, those records, they're dependent. What are the implications of that? You're going to learn over time. But you don't need to like keep going concept to concept, one step at a time. You just give a small language, let people play around. And I think that leads to a much deeper understanding of the problems overall. So yeah, that's how it's a bit of different from how people see dependent types. People see dependent types as like, I'm gonna go to Coq and write a theorem about it. Yeah, I don't think it's like, I think that's pretty cool, but I don't think that's my goal overall.
I like that. Like making it more digestible in the sense of useful, making it more useful for actual programming languages for you to help you instead of hindering you, right? That's really.
Speaking of being useful as a programming language, I thought it was interesting that it's a strongly normalizing language, right? Have you found that to be restrictive at all for some of the programs that you want to express?
I think there is a very easy solution. Like you add escape hatch to a monad, and now everything that you want, or like hopefully through algebraic effects, but right now it's through a monad. But it's also like, it's not very common for you to write non-total functions. Whenever if I go through the OCaml standard library, almost everything is automatically strong normalizing. It's very few cases that are like, for example, type checking is one of the cases that doing it on a strong normalizing language, it's harder to say the least. But and in the worst case, you're gonna hit Godot incompleteness theorem. But I think almost all the cases you can just decompose your problem until almost everything is strong normalizing, and then for the remaining piece, you just tie it using a monadic fixed point, and it's really not a problem. I remember I have a friend, which is also an OCaml developer, Antonio. I remember him playing around with Coq, and he was like, "Oh, so Coq is Turing complete." I thought it wasn't. I was like, "No, you're just not relying on Turing completeness anywhere. You're just like doing structural recursion. You're doing a fold over a list. You're recursing over a natural, and all of those are very natural. Like people think about a for loop, right? The average for loop is strong normalizing. It goes from a number to another number, and that's about it. And at first I was also like, strong normalization is too big of an issue. And I think it is in most cases, because that means you need to introduce type universes, and I think that gets annoying quite fast. But if you can avoid that problem, I think it's really convenient. And but yeah, I also have couple views on how to like bridge the gap between strong normalization and not strong normalization. But overall, for me, the main trick is like just color the functions, and that's about it.
Awesome. Let's go back a little bit when you were saying that you started working with programming languages, with compiler, when you were doing some work with some JavaScript Angular. And can you tell us a little more, like how was this transition into programming? Because apparently you found something, because you're still working with it, right? So you found something that you enjoy, that you like. Then by the way that you're speaking, I would even say that you might be passionate about it, right? So how was this? How was finding this, and how did you start working and learning more about this?
I don't think I was that passionate about it. I just think I felt like some dopamine whenever you make a pull request that is like 15,000 lines of code changed.
Wow.
And like 5,000 lines of code deleted. You're like, come on, I'm a programmer god now. And
just want
it
a
was
drug, right?
Yeah, exactly. Like keep going. And I think that was mostly how I felt about it on the beginning. Of like, hey, this is super powerful. I can do the job of like 100 men in a week. Of course, it's only if there is the low-hanging fruits and whatnot, but it felt really good. But then I started also, at the time, functional programming was getting more popular. Actually, before I started working, that was already the case. I remember watching some go-to on the Lambda calculus, and a friend of mine, an old friend of mine, was making compiler videos using functional programming. And ES6 had happened, so we had arrow functions. And there was all the drama around promises and the Fantasyland drama. That was a fun one. And so I just kept going. And at some point I got into OCaml, which was like, come on, static typing is not that bad. Because remember, I was doing Minecraft modding. So my experience with static typing was C and Java, which...
it's bad.
Yeah, it's not fun. And so I started playing around with ReasonML, which at the time had some momentum. And I was like, that's pretty cool, this inference thing. It's like, yeah, at first, the error methods are kind of weird. But after 3 months, you're like, no, it makes sense. And then from that on, I just kept going, thinking about it. I made 1 or 2 contributions to OCaml. At some point, I got into backend. I did one that I'm proud of. At the time, I ported OCaml to macOS ARM64. And that is a funny one because I actually had the patch 2 weeks before the announcement. But I read the news because I was porting it to iOS. But I had read the news of like everyone was saying, okay, Apple is actually going to move towards ARM64 for the laptops. And I was like, that makes sense. They have the best single core of the market at the time. And I just held the patch. And one day after, no, I think it was exactly the same day for WWDC, I just showed up with the patch and everyone was like hyped.
Our savior. That's awesome.
Yeah, exactly. And then we got access to an Apple development kit at the time. And that was a really good one. And so I just kept looking, and I dived a bit on the OCaml type checker at some point. I don't think I made that many patches. I think I made one small patch that was not even user facing. But yeah, I kept going, and I don't think programming languages is that special to me. It's like I've been doing it a lot because I think it's I use programming languages daily. But I also got very deep when I was working as a blockchain engineer. By the way, blockchain engineer here meant I was making a blockchain, not I was writing smart contracts for a blockchain. So distributed systems and whatnot. On that job, I actually ended up needing to write compilers and interpreters and virtual machines and things like that on a daily basis. So yeah, that was about it.
What are the kind of resources that you use to get yourself started with programming languages stuff?
My boss at the time, he was like, "You seem to understand a bit of programming languages. How much do you learn? Do you understand about type theory?" And I was like, "I don't know." And he sent me a paper, which is an introduction to system. It's actually the notes of a professor. It's an introduction to System F, STLC to System F Omega, and I was like, there is a lot of Greek letters. But at some point, I just, sat on my chair and was like, okay, let's go and search every one of those Greek letters. And turns out that it was pretty straightforward, and now I know the Greek alphabet. It's a side effect, I guess.
Yeah.
But yeah, it was not super. It was not straightforward, but it was not exactly hard. Like, people are super afraid of notation. And I think especially now with something like ChatGPT, you can ask about the notation.
Yeah.
But at the time I didn't have it. So I was like, okay, I probably spent a week just learning syntax. And I know a lot of programming languages, so learning syntax again was a weird feeling because, most languages share syntax to some extent. Well, of course, Haskell and C don't share syntax, but it's like if you learn one of their family, you can relate to. But nowadays, I love Unicode. I think everyone should be using Unicode to program. But I know that people are super afraid. So if they see a for all symbol, they just go out, which is sad. But I really like the notation that we use for doing type theory. I think it helps a lot to visualize the concepts right now I'm a big fan of it. At the time it was a pain, but I think that's most notation overall.
Fair enough. That's nice. Yeah, I was curious because most people that I know usually either start with software foundation, or hacking around with Coq because they knew some Haskell, so that was the next immediate step, right? Or even after that or during that, you take TOEFL, right? Like Pierce's Red Book, types
Yep.
and programming languages.
I think that was the only book that I read in the last couple of years. Actually, no, I also read Dom Casmurro, the Brazilian book. It's pretty good.
That's a really good one. Hope more
But
people read that.
But I read types and programming languages much later. I was actually trying to learn about subtyping properly, and I opened the book and there was first. It's amazing that the book has a map of like, if the dependency map for each chapter.
Right.
And then I just followed the dependency path until I got into subtyping, and I actually ended up reading half or most of the book. I did not do any of the proofs, but it was actually a pretty good book, and I still recommend it.
Yeah. Did you? So we've been talking a lot about Coq, ML, Haskell. Did you play with Lean by any chance?
I did not play with Lean.
Mm-hmm. Yeah, because I'm still curious, because I definitely agree with you that Coq is probably one of the, the most amount of programming language engineering that exists. Like, it's the most robust programming language there is. I'm quite confident of that. Maybe I'm wrong, but it is a lot of work. It's a masterpiece, I'd say. But Lean is also very amazing.
Yeah, Lean seems to be better. No,
exactly.
overall,
that's why I ask. Yeah.
I think the main reason why I still like Coq so much is because extraction to a camel feels very natural to me.
Yeah.
I don't know the Lean strategy to compile and run the program, but yeah, it's amazing. Like, Terence Tao.
Yeah.
I don't know. Playing with Lean is amazing.
Yeah.
People doing proper mathematics.
Yep.
And here in Brazil, we have a couple cool kids teaching Lean. Like Sophia did a YouTube stream on Lean 4, and
I
she
saw
got
that,
like
yeah.
1,000 views and whatnot.
Mm-hmm.
I'm like, that's pretty cool, you
That's
know?
nice, yeah.
Dependent types was not even a thing like 5 years ago. So seeing someone talking about it, it's pretty cool. And but yeah, I did not play with Lean. I still want to play more with Agda.
Oh yeah. Yeah.
I did play a bit with it, but it's not something that I have a lot of intuition. I want to both learn a bit more about homotopy type theory and also there is a couple cool features in Agda, like size types and whatnot,
Mm-hmm.
that I want to play around.
Yeah, those are fun. Those are pretty cool. There's a lot of interesting theory going on in this field. It's very exciting. I don't know. I feel extremely excited to be living at this moment for, like in the terms of type theory, because things are just gaining traction. Things are just becoming big. Like Terence Tao doing this tweet,
Yep.
it's just such a huge amount of views going on, and like all the eyes are gonna be turning to this stuff now. I don't know. I feel that it's blowing up. We're
Yep.
gonna be the cool kids. I don't know.
Yeah, I hope so. I think I'm not so optimistic, I would say, but
I think so. What I feel is, like the math community and the programming languages community are definitely kind of colliding right now, and that's extremely exciting to me.
yep. I also want to learn more math in general.
Yeah, yeah.
Like, I don't know a lot about it. I just know random topics, and sometimes it's useful,
Yeah. I think that's also kind of one of the issues of being self-taught, I would say, is because you get very specialized in one thing. And when you go to say, like you go to a course, you get this broader view. You do some bunch of stuff that you wouldn't do on your own because it's boring, you don't care, or it's not your goals.
I don't feel like I have that much on it. It's just that like some topics, for example, the classic one for me is linear algebra. I'm interested on it, but I should first probably go to play around and write a game engine or something like that. And it's something that I know about a couple of things about the terminology. I know a couple of the tricks, but I never got too deep. I probably would not pass on a linear algebra course a test right now. But I think, at this point, if I spend like a month or two, I have enough background to put it around. But it also depends on the quality of the course, right? So some are pretty straightforward. But yeah, I think it's mostly a matter of like, if you're self-taught and you stop, sure, you're gonna suffer that problem. Like if you are afraid of anything. And that also aligns with my view of like, I'm not a programming language engineer. I'm not a blockchain engineer. I'm not a front-end engineer. I can write software. If humanity as a whole knows how to write it, I should be able to in a couple months. And that means that over time, I think my knowledge is getting way broader. So like I mentioned, distributed systems. I also know a bit about operating systems, virtual machines, and whatnot. And so, but it's really easy to fall for the trick of like, this is not my domain.
Right. Yep.
But it's like, if you're self-taught, that was not your domain to begin with.
Nothing's gonna be your domain. Yeah.
Yeah, exactly. It's like, what are you talking about?
Right.
But I think it's common for people to fall for this. Overall, my main thing is like, come on. That's just kill issue, Go there, play a bit, learn a bit.
Yeah.
But yep.
I really appreciate that when you say, like just don't be afraid. Just go for it. If humanity knows how to do this, there must be some resource that you can catch up if you just spend enough time on it, right? Yeah, that's really nice. What about your motivation for doing Twitch streaming, YouTube coding? Where did that come from?
Remote working is sad.
So the same reason why I have this podcast.
Yeah, it's just like remote working is so. I like not needing to leave my place to work, but at the same time, on the social aspect, is like not really that much fun. And so at some point I was like, yeah, sure, well, let's do it. And yeah, it also helps you to focus a bit, because you more or less you can go and scroll Twitter for 5 minutes, but if you do more than that, people are like, is that a Twitter stream now? So you go back, and yeah, it helps me focus. And yeah, I try to do most of whatever I'm doing on Twitch, because sometimes there is some people that are actually interested on it. So sometimes we got people related to papers that I'm writing, that I'm reading. Sometimes we get people from people that are working on their programming languages. Sometimes we get just very smart people that are like, I think this problem is related to that other problem that you never heard of. But it's also like, sometimes it's just cool to go stop and explain to people. If you can do that well, in general, that means that you have a good intuition for it. So it's a good way of checking. And if I go and say that a monad is just a monoid in the category of endofunctors, it doesn't help that much. But it actually helps if you keep going. If you try, okay, sure, you don't know what is a monad, nor an endofunctor, or a category. Okay, let's try to go with a monoid. And at some point, some people, not everyone, but some people are going to be like, oh, so that's just a monoid. And you show a type signature for them, and they're like, yeah, no, that's just a monoid. Oh, what is a monad then? What is an endofunctor? It's just a functor, same category thingy. What is the category? Don't focus on that much now, but so here is the type interface for a monad, and now you can see, oh, it's just those two operations. The category is preserved. It's a good way of ensuring that you actually understood the edges of your knowledge, because otherwise, whenever you go to explain, you can say a monad is just a monoid in the category of endofunctors and whatnot. But then, what is a monoid? What is an endofunctor? What is a category? What is a functor? And I think for me it was super helpful overall. That's also how I improved my English a lot.
Oh yeah. I have pretty good English, yeah.
Thank you, sir.
What were some of your first Twitch streams like? You were you went online and you were like, I'm going to work on whatever problem it was, and there were 0 viewers, and you kind of did that. What problems were you working on that you...
The first ones, I think it was something about front end. Yeah, I think so. I think the first ones I was actually playing with Haskell. Now that I remember, I was trying to learn Haskell, but then I start searching for a job again, and then I start writing front end for the job application, and yeah, at first it was 5 people. Then I got rated a couple times, and over time, it started growing up. But there is an issue. If you have more than X amount of people, it actually starts consuming your time too much. So it's 50 is pretty much the limit for me. And so sometimes I start caring less about the chat, and people get sad. And they leave. So it's overall my stream averages between, when I'm doing it in Portuguese, it averages between 40 to 60.
Oh, wow.
In Portuguese, in English, because most of my public was in Portuguese at first, it's 20 to 30 or something like that. It's still plenty, but yeah, it's a bit less. But yeah, it's mostly go there. As soon as you start to get really deep into programming languages, actually start losing public, because some people are great and their feeling is I have no idea what you're doing, but I'm gonna keep watching, and they keep watching it sometimes for 6 months, and they're like, I still don't know what you're doing, but now I know one thing. But some people are just come on, I have no idea what this dude is working on. I'm just going to go watch something else. And Like, that's fair. It's just that, and at this point, it's like I cannot just stop and explain everything from scratch.
Yeah, every single time
It's-
someone joins, yeah.
Yeah, exactly. It's like it's way too much missing knowledge. But I try sometimes to be like, hey, let's stop and spend an hour saying, explaining what am I doing. Sometimes when I get raid, I'm like, okay, so we have a different public. Let's try to be nice. But yeah, for me it's just like I don't intend to get money. I don't intend to get famous. It's just a way of being like working in a more social environment overall. That's about it.
Working from home is weird, right? Because like there are so many good things. Like it's really pleasant. You're home and everything else, and often enough you don't have to deal with some very annoying coworkers or like those people who can have those very loud keyboards. Ugh. But at the same time, human beings, we're complex and we kind of need this social interaction. Oh, there he is with his. Oh, that's not loud. That's a good one. That's a good keyboard.
Yeah, that's not that loud. It's just
Dude, there's some people in my lab that, oh my god. Anyways,
Yep.
but yeah, human beings, we're complex, and we even though we get frustrated and tired of social interaction, sometimes we just need it, right? It's part of being human. But one thing that I was gonna say is, I think all from in all the platforms to consume knowledge, right? Like we can read papers, we can read books, we can watch YouTube videos, we can have podcasts. There are a bunch of different things. One thing that I have a lot of trouble doing is Twitch streaming, and I don't get it because I feel that some people really like to have something in the background and like look at it sometimes and go back to work. I don't understand. Like that doesn't work for me. Is there something particular about watching Twitch streams that?
I think for me it more or less works. For the same reason, because of the same reason how I learn, which is completely chaotic. So it's like if you're doing something completely unrelated, and you're listening to someone talk about something that is slightly outside of your domain, but you more or less understand it. I think you just kind of learn by hearing. So like, and that is, that's kind of how most formal education works. It's just like you're hearing it, and sure, maybe you're super focused. I know for a fact that when I was at school, I was not super focused. I was probably thinking something completely unrelated, but if you more or less have the needed the dependency tree for the knowledge, I think you learn. But it's also like it's just fun. It's just like people are playing around. Sometimes we start discussing something completely unrelated. Sometimes I watch YouTube videos on physics and math, mostly on physics nowadays. And it's like, time to watch some YouTube video. Let's watch a YouTube video. And if you don't want to listen now, you just mute and do whatever you want.
Leave it there.
So
right.
Low effort, but it's fun, I would say.
Right. Just learning by, what's the name? Like
Osmosis.
Yeah. Sometimes, right? Yeah. Okay. Do you have any other question then? You seem pensive over there.
Yeah, I don't know. I think we covered quite a good span, especially of... Is there anything, Eduardo, that you want to cover? Anything that you want to promote out to our audience?
I would just ask, if you want to chat a bit, just show up on my stream. Is twitch.tv/EduardoRFS. It's just pretty much the same handle as mine on Twitter. I've been doing this language, as I mentioned. I've been writing Teika, which is a dependently linear type language. Hopefully, in a couple months, we can have a couple compelling demos. But yeah, that's about it.
Before we finish, I still have two more points. First of all, I think I saw somewhere in some tweet somewhere that you were planning to get a company. out of the ground in the next couple of years? Can you tell us more about that?
I think on the next couple of years, I want to start a company. We tried a couple ideas recently, but they were bad ideas. Me and a friend, we kept working for a month nonstop. And at the end of the month, we were like, this is not going to work at all. So let's go to the next one. Mostly because, I don't know, I think it's a better way of making money in the long term. But also because I kind of like the idea of working on something that is not mine is not on something that I believe.
Right.
And that has been a problem for me, like working on projects that I don't think make any sense.
Yeah, I hear
And
you.
so that's about it. Hopefully, if I make Teika work in the next 3 years, hopefully I can work maybe even a consultancy on the language.
Mm-hmm.
But I'm not hopeful on that. Like I don't think it's likely to happen. But no, who knows? Maybe I do a good enough job. But yeah, that's about it.
Do you have some things that has been in your mind, on things that you would really enjoy to make the company on, and if you could make it work down that road?
Yes, I think operating systems are all bad, and that we should stop relying on virtual memory to guarantee safety, both because that has been eating our performance. So like right now, the bottleneck of any HP server has been I/O, but not like I/O because your network card is too slow, or because your SSD is too slow, but because switching to the kernel back and forward is bad. And we tried things like I/O, U-ring, and whatnot. But just to give a notion of how bad it is, Google disabled I/O, U-ring on all Android devices and on their internal servers, because it was just like at some point most of the exploits that allowed you to bypass the kernel was on I/O, U-ring, because it's not a trivial problem. So I think it's a good time and a good opportunity to start working on a different design. For example, maybe we could run WebAssembly on the kernel, and there is a couple of tricks that would make it even faster than running native x86. But even if you want to run native x86, you could there are tricks that you could do to achieve that without going full-fledged virtual memory hardware support. And also Spectre, Meltdown, recently there was Zenbleed. It's pretty clear that relying on virtual memory to ensure like safety at this point it's not great, and it's gonna keep getting worse. And sure, there is some issues that are inevitable on that, but yeah, I believe that we could do better. The problem is how to make that a company is annoying. I've been thinking on the back of my mind, but I do not have a solution yet.
Just come to the Bay Area. People would throw money in your face.
I wish. Zero interest rates are not a thing anymore.
Yep,
Sadly.
it's true. And finally, to wrap up, final question on your Twitter. First thing you see is that you hate floating points. Tell us about it.
Yeah, I describe myself as an anti-floating point developer. Mostly, people are like, floating points are rational numbers. They are not.
They're not.
And you may think, oh no, multiplication is commutative,
Right.
and associative, not on floating
Not
point. Division, if you multiply by n and divide by n, it should be equal to x, not on floating point. If you compare numbers on floating point, you may expect that some behavior is going to be preserved. It's like, yes, but that's only if you're looking at the number. If you put some operations on the left side and the right side, it's not going to preserve. I've been bitten by it a lot in the past. And I think for modern computers, unless you're doing something like very compute intensive, just not worth it to have the trade-offs. And it's one of those things, it's like no pointer exception, right?
Yep. Yeah.
It's like low hanging fruit. It doesn't hurt anyone to drop that, except, if you're doing some very crazy optimizations that rely on that. But it's so annoying to see you go on a page and how much money you need to pay nan. Like, come on. And so
What are the other implementations that we can have instead of floating points?
I think decimals are better overall, right. Bounded decimals. Mm-hmm. But I just think overall rationals. The problem of rationals is that you need to have at some point you need to trim them down, because otherwise they keep slightly growing over time.
Right.
But if you just have a database and you say, hey, I'm gonna store up to like 100 digits, that's not going to be your bottleneck. It's still crazy fast to do operations on those. But yeah, there is rationals, there is bounded decimals, there is even binary decimal floating point, which solves some of the problems. So people are always crazy about .1 plus .2 not being equal to .3. That is solved.
Yeah.
But it's still, I don't know. I think for most systems, it's just not worth. It's just not a thing that you want to think about. Come on, commutativity and associativity should be preserved, and that's about it.
Dude, I actually initially asked this question because I hate floating point myself. I worked in a job in the Bay Area one time that our job was literally to verify that the floating point unit inside the CPU was correct, right? Because they didn't want one of those Intel things. So I had to learn inside out the IEEE 754 thing. Dude, that is so full of corner keys, so nasty. I mean,
it's stupid.
I don't mean any harm to people who actually done it, because I was working with a guy that was one of the guys behind the 754, and he's one of the smartest people I've ever met. Don't get me wrong, okay? But honestly, the feeling that I have is that I was impressed that we got to the moon, and this is still the kind of irrational number that we were working with. This is it's bad. it's bad.
Yeah, it totally makes sense if you remember the time that it was made and the requirements.
Yeah.
It's by far the fastest approximation to rational numbers that we have.
There's so many corner cases, so many things can go wrong. There's those flags. There was one point that I was extremely confident that I got a bug. I caught a bug in our implementation, and I'm like, yes, this is a bug, because if you look at the IEEE, this is what is said, blah 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 blah. And then we send an email to this guy in there, and he's like, yeah, this is actually a common misunderstanding of the spec. I wrote a blog post about it last month, so he just sent me the blog post, and it was there, exactly my problem. I'm like,
I understand.
Oh man, yeah, it was very frustrating. Anyways, I'm glad that I took this out of my chest. So, thank you so much for being here. It was a very nice conversation. Thanks, Dan, for being here in this cold morning for you. Yeah, it was very nice meeting you, Eduardo.
Thank you so much for inviting me.
Well, that was it for today's conversation. I hope you guys enjoyed it as much as I did. And I must tell you, I'm impressed. This dude, he's smart. Honestly, I think he's very smart. And I don't know, I wish I have had his drive. I feel that if I didn't go to classes and the professors didn't force me to learn some things, I would never have, put a paper and try to figure things out on my own, or get a book, read through a book. It's really hard for me. Sometimes I feel that I just work under pressure. I don't know. Do you guys ever feel like that? Don't forget to join our Discord. Oh yeah, and if you liked this conversation, don't forget to check Rafael on his social media, his stuff. He has a Twitch, YouTube. You can find all of those links in the description of the show. And that's it. That's it for today. Oh yeah, one thing that I wanted to mention is that I had to turn down the comments session in the website because it was really flooding the website with a lot of advertisements. So that was really annoying. So I turned it off. Anyways, I hope to see you guys next time, and Merry Christmas. Hopefully we're gonna have another episode later this month, but otherwise, Happy New Year as well. Let's go 2024.